Good morning.
Good morning.
How is everyone today?
Pretty good.
So, anybody do anything amazing over the weekend? I kind of missed that yesterday. Anything amazing? Nothing.
I made a Texas sheet cake.
Yeah? Is that your first time?
Yep.
Nice. So, did you bring it to your Talon math class and share with your fellow students?
No, I didn't.
Well, how are they going to know, like, quality control and that kind of stuff? I think.
Well, I'm bringing Jill a piece tomorrow, but everyone
Okay.
else is sick, so they don't deserve my cake.
Well, Jill's probably the expert anyway, because she'll compare it to her mother's. So, very good. All right. So let's see. All present and accounted for in Joseph City?
Ricky is gone. He's sick.
Okay. Ricky. Okay. Let's see. And then in Holbrook, let's see. Hold on just a second. We've got a lot of people out for the parade. So you guys help me out. We've got Andres and Cyrus and Hannah and Jocelyn and who else?
Raylan.
Okay. And is that it? Everybody else is here? Awesome. Thank you. So, first thing is that I did check, and anyway, I was very pleased that everyone was able to do the Moodle day yesterday that took the quiz, even though we had a little issues with the basically what I kind of did a test thing today, and so let's say normally I have a quiz already done for my other trig class. All right, now I've already made it random and everything. Then basically what's happening is, so in the past what I would do is import the quiz into the other section, and then I'd be good to go. So apparently by making it random so that I can count your highest score, when I try to import it, it's not importing the test bank, the quiz bank with it, the question bank. So when it searches for random questions, it just takes them from wherever it wants. So I actually am not sure where those questions were coming from, because when Ms. Smith was telling me about initially some of the questions, I don't even know where they were coming from. What question bank? I just know it wasn't from 6.2. And so anyway, so that was kind of weird. But I was very pleased that once we got that ironed out, that everyone was able to take the quiz. And, anytime the quiz average is over, I think it ended up being like a 4.3 something. So I'm happy with that. I hope you are too. So what I decided to do was count yesterday as, for attendance purposes. I went ahead and gave everybody credit for being here because you took the Moodle quiz. I asked you to be here to take the quiz. You were there, so I went ahead and gave you the attendance points for yesterday. Okay. So anyway, so just to let you know about that. The other issue I want you to know about before we get started is that since, the middle to late part of last week, there have been some issues with the video that for some reason it's not recording or uploading or whatever. So I'm just kind of doing the best I can to deal with it. So, for example, last Thursday's recording, if any of you were absent and you go to look at it, it didn't record. Okay. So, but what I did do is I recorded that my afternoon trig class did record. So I'm teaching the same stuff. It's just you won't recognize your beautiful classmates on the video. It'll be the different class. So, but it's already posted, and if you watch it and you were gone for school activity, you can still get the same points. Just know that I'm just hoping that, like I only teach one Talon calculus class, and so if it doesn't record, I have no backup. Okay, so we'll just do what we can. Okay. All right. Any other questions, comments, concerns before we get started? Okay, so like I said, I felt pretty good about how the Moodle day went, at least from my end. We did have the one glitch, but what I'm thinking about doing is like on President's Day, where I think both Holbrook and Joseph City have that day off, but MPC doesn't. So then so normally we would have a regular lecture, and you'd have to come in, whatever, those days happen. But what I'm actually thinking about doing is maybe making that day another Moodle day where you could even maybe take it at home, take the quiz at home, so that if that's the only class that you have on President's Day, that you can stay home in your pajamas and just take it at your convenience. Okay, so that's kind of what I'm shooting for. All right, I can get all my ducks in a row there. All right, any questions on that? Comments, concerns? All right, so we've got a couple weeks to figure out where we'll be and what that is going to do. So anyway, okay, well, let's go ahead and get started. We are on 6.3, and we are on the back side, first column near the bottom, and we're writing down a few sets of identities. Okay, so the first set are the reciprocal identities. So this is pretty important that you know, and I've talked about this before, that you know which are reciprocals of which. And so you need to know that sine and cosecant are reciprocals. So 1 and 2 is how we write that mathematically. And cosine and secant are reciprocals. So that's 3 and 4, and then tangent and cotangent are reciprocals. All right, anybody need any more time on that page? Okay. All right, next we have two quotient identities. Because tangent and cotangent can be thought of as a ratio of two other functions. So tangent of theta is sine over the cosine of theta. And cotangent is the reciprocal, cosine of theta over the sine of theta. All right. And then we have the three Pythagorean identities. The first one is probably the one that you need to memorize. Sine squared plus cosine squared equals 1. I'll put a little star by that one. The other two are also Pythagorean identities that we get from the first one. So like if we take sine squared plus cosine squared equals 1 and divide everything through by sine squared, then we get the second one. 1 plus cotangent squared equals cosecant squared theta. If we take sine squared plus cosine squared equals 1 and divide by cosine squared, then we get the third one. Tangent squared theta plus 1 equals secant squared. So this will help us big time in, we'll use these all the time in, let's see, I think chapter 7 and 8, we'll use these a lot. Okay. All right, next. Okay, so next is what we call I'm reviewing the definition of complementary functions. Okay, so in geometry, if we have complementary angles, there are any two angles that add up to 90. Okay. So a complementary function in trig, well, if we have like the complementary sign, what that means is like the sign of the complement. So like 20 degrees and 70 degrees are, here, let me go ahead and up this screen. So 20 degrees and 70 degrees are complements because they add up to 90. So the sine of 20 degrees is equal to the complementary sine of 70 degrees because they're complements. Okay. Now, the abbreviation for complementary sine is cosine. That's what the co means in front of cosecant, cosine, and cotangent, is it's actually short for complementary. Okay? So the cosine means the complementary sine. So the sine of 20 degrees then is equal to the cosine of 70 degrees. Or the secant of 10 degrees is equal to the cosecant of 80 degrees. The complementary secant. And so the complements, the angles are ones that add up to 90. Or the tangent of 30 degrees is equal to the complementary tangent or cotangent of 60 degrees. Okay? So now let me give you the formulas that say this. Okay? All right. So cofunctions of complementary angles are equal. If theta is an acute angle, then, okay, now, so I have these formulas written down in both degrees and radians. So the sine of 90 minus theta is equal to the cosine of theta. Or the sine of pi halves minus theta is cosine of theta. So you can add this in radians if you want, or you can just keep it in degrees. Most students remember it better with degrees. Cosine of 90 minus theta then would be sine theta. The tangent of 90 minus theta is cotangent theta. So the cotangent of 90 minus theta is tangent theta. And then the secant of 90 minus theta is the cosecant of theta. Cosecant of 90 minus theta is the secant of theta. So if you just want to write down the blue part here, then that's fine. I've just put it in radians as well. So the last one, I guess, I need to put in radians. So that would be the cosecant of pi halves minus theta would be equal to the secant of theta.
So Mr. Strong, I have a question.
Yes.
So you say the sine of pi over 2 minus the angle would
Yeah.
be the cosine of the angle?
Yeah, so let's say if you have here, let me go through a couple of examples.
Okay.
I think it'll be easier. So then the cosine of 20 would be the sine of 70. So they're cofunctions. So if these angles are complementary, it will work. So that's angles that add up to 90 or pi halves. Now, it is a little tougher with the radians because with the radians, the cosine of pi fourths, you actually have to calculate pi halves minus pi fourths, which is also pi fourths. So this cosine of pi fourths is the sine of pi fourths. Okay? So the cosine of 45 degrees is the sine of 45 because those add up to 90. Now, one thing though is remember in trig we can have negative angles, whereas in geometry you can't. Okay? So like the cosine of negative 10 degrees would be equal to the sine of 100 degrees because these two angles add up to 90. Okay? Or the cosine of 200 degrees is equal to the sine of 110 degrees because these two angles add up to 90. So the tougher ones are the ones in radians because you have to subtract the angle from pi halves to get it. Okay? All right, so go ahead and try practice 3A, both of them, part 1 and 2. All right, so Madison, what do you have for the first one?
Sine negative pi fifth.
Okay, now it's going to be cosine. And then to get the angle, you subtract from pi halves. So it's actually going to be 5 pi 14ths. So let's look at that. So pi halves minus the angle that you're given, pi sevens. Well, you got to get a common denominator, 14. So this is 7 pi 14ths minus 2 pi 14ths. And so that would be 5 pi 14ths. Okay? So just kind of seeing how well we do the fractions there. So,
Mr. Strong,
go ahead, please.
So you're saying that for the cofunction of sine pi over 7 is the cosine of 5 pi
Is
over
equal to
is
it's
equal
equal to the cosine of the complementary angle.
Okay, got it.
Okay. So the degrees ones are easier to do. So the tangent of 43. Let's do that one here. All right. Anna, what's the tangent of 43 equal to? So it'll be the cotangent, because that's the complementary function. So the complementary tangent is the cotangent. And then what's the complement of 43 degrees, Anna?
47.
47. Yeah. So the answer would be the cotangent of 47 degrees. All right. Any questions? Okay. All right, so this last part is to find the value of any trig function. Okay? All right, so this is the process we're going to go through. Number one, determine the quadrant and draw the triangle. Okay? And then number two, find the third side of the triangle and then the trig function. Now, typically when we draw the angle, if it's in the first quadrant, it's, coming up from the x-axis. And if it's in the second quadrant, come up from the x-axis. And if it's in the third quadrant, go down from the x-axis. And if it's in the fourth quadrant, come down from the x-axis. So just like the reference angles, when we draw the angle, draw it from the x-axis. Okay? That'll kind of help your drawing look right. Okay, so let me just kind of show you, and you just kind of watch on this one. All right, so let's say we want the cosine of theta is negative radical 3 over 2, and we also know that the tangent is negative. All right, let's say we want to find the tangent of theta. Okay. All right, so if we want to find the tangent of theta, then the first thing we need to do is figure out what quadrant we're in. So in what quadrant is the cosine negative and the tangent negative? So now it would help if you remember that the awesome students take calculus, what that means. So can anyone tell me in what quadrant is the cosine negative and the tangent negative?
The second one?
The second one, very good. Because the cosine, see, is negative in quadrant 2 or 3. The tangent is negative in quadrant 2 or 4. So that means we've got, by process of logical reasoning there, that means we've got to be in quadrant 2. All right? Anybody need me to go through that again? Okay. So we're in quadrant 2. So then the next thing I'll do is say, all right. So the next thing I'll do is draw the angle in quadrant 2. Okay? So here's my triangle in quadrant 2, and I'm trying to find theta. And I know that the cosine is negative radical 3 over 2. So then that's adjacent over hypotenuse. So here the x is a directed distance. It's going into the negative direction in quadrant 2. So negative radical 3 over 2. Now, to find the tangent, I need to find the third side. So I can do opposite over adjacent. So how do I get the third side of the triangle? If I know two sides.
Pythagorean theorem.
Pythagorean theorem. And so this, oops. Actually, here, I guess I didn't even do the Pythagorean theorem. But I could have. Let's see, did I do it over here? No. Here, what I actually did is I recognized that this was a 30, 60, 90 triangle. So, because it has the ratio of 1 to radical 3. So I knew this third side was 1 just because I've dealt with that triangle enough. Okay? And it's positive in the sign, the y value is positive in the second quadrant. So then I know that the tangent is opposite over adjacent. So the answer I'm looking for is 1 over radical 3, which if you rationalize the denominator, negative radical 3 over 3. So either of those answers would be appropriate. Okay? Okay, so see if you can do practice 3B, just the first one. All right, so Madison, if the sine is positive and the tangent is negative, then what quadrant are we in?
Wait, what did we think?
So the sine is positive 1/2.
Is it quadrant 2?
So we are in quadrant 2. Okay, everybody cool with that? Any questions? Okay. All right, so Lauren, what would be the final answer? What's the cosine of theta there?
Is it radical 3 over 1?
Okay, now wait, let's back up. In quadrant 2, is the cosine positive or negative?
Oh, it's negative.
So it's got to be, so your answer has to be negative. All right, so now say the other part again.
So it's negative radical 3 over 1. So just negative radical 3.
Right, so negative radical 3 over 2. Because it's see when you label your 1/2, see it's opposite over hypotenuse, but then for cosine it's adjacent over hypotenuse, so it's over 2, not 1. Does that make sense? Okay. And then remember, cosine has to be negative in quadrant 2, so your answer has to be negative. All right. Any questions on that? Now, now I know that you're kind of used to drawing sides of triangles where they're always positive, and that's true. Sides of triangles have to be positive, but see, when I'm measuring, like if the x is going to the left, or if the y is going down, then I label it negative just to help remind me that it's going to be negative in the second quadrant. Okay. All right. Okay, so now let's look at this one. It says, okay, the cotangent of theta is 0.4. Theta is in quadrant 1. Find the sine of theta. Okay, so this time we're told the quadrant. So what is this? So will the answer be positive or negative? So it'll be positive because we're in quadrant 1. All right. So the next thing I like to do is draw the triangle. So we're in quadrant 1. Okay. So now 0.4, that's the same thing as, that's the same thing as 4/10 or 2/5. So then if the cotangent is 2/5, that means the tangent is 5/2. So I use that reciprocal identity. Okay. And then that helps me draw the correct triangle. So then tangent is 5/2, so that's opposite over adjacent. And so that's not a triangle that I know. And so I do need to use the Pythagorean theorem to find that third side. So I have 2 squared plus 5 squared equals c squared. Add them up, take the square root. So I get the square root of 29 is the hypotenuse. So then the sine is opposite over hypotenuse. So the final answer here would be 5 over radical 29. All right, any questions on that example? All right, well, go ahead and try practice, the last practice problem there. All right, so Avery, when you've got the cosine of theta.
I believe it's -3/5.
Very good. Any questions on that?
Can you go over it?
Sure. Okay, so first, so you in quadrant 3, so you want to draw your triangle in quadrant 3. And so that's down here from the x-axis. So the sine is the opposite over hypotenuse. So the opposite, -4/5. So now you're going to use the Pythagorean theorem to find the third side. Well, actually, that's a 3, 4, 5 triangle. So you could probably see that it's going to be 3. But since it's going to the left along the x-axis, you would probably write A is -3. Okay, because as a directed distance. So then the cosine of theta would be adjacent over hypotenuse, so -3/5. All right, so Seth, what would the tangent of theta be?
Is it 4/3?
4/3. Yeah. Yeah. Here you could actually just say, look, it's the opposite over the hypotenuse. So -4 over -3, which would simplify to 4/3. Okay. You don't have to go through all that. Okay. All right. Any questions? All right. Well, I was going to try to talk you into taking the quiz on this tomorrow, but I'm not going to because there's so many people out in Holbrook, and then we've got Ricky gone, and then with having some issues with the videos, I'm not sure they'll be available before class tomorrow anyway. So what that means is tomorrow we're not going to do a quiz at all. So I would suggest that you take advantage of the time to go to the tutoring, attend the tutoring session. Okay? If, this is a perfect opportunity. I know later in the semester people say, what could I do to improve my grade? Blah, blah, blah. Okay? Go to tutoring. It's provided free. You could just sit down and do some practice problems from any of the sections and get some help while you're there. But no quiz tomorrow. All right, and but we're going to go on to 6-4. All right. Okay. So 6-4, the focus is going to be graphing. So you probably want to grab your calculators because I probably will get to some graphing here in the next 15 minutes because that's the big idea is graphing. We're going to talk about period and other aspects of the graph, transforming the graph, and then finally we'll end up with what we call damped harmonic motion. Okay, so I know we won't finish this today, but probably on Thursday we'll finish it. Okay, so first of all, let me give you an idea of what some of these look like, just some basic ideas. Okay, this is the sine function. Okay, so the sine wave goes up and down, and it actually goes on forever in both directions. Now, we say that it has a period of 2 pi. that means that's how long it takes to complete one cycle. So if we start here and we go up and down and then back to where it started at along the x-axis, that distance is 2 pi. Okay, so that's the period. Now, you're going to see that the sine and the cosine look an awful lot alike. So one of the things that I would suggest you memorize is that the sine graph passes through the origin. Okay, so it goes through the origin. Now, the highest that the sine graph goes is +1. The lowest is -1. Okay, it's just some kind of things, some general ideas. Now, the cosine starts, well, it also goes on forever. It also has a period of 2 pi. But the big difference between the look of the cosine is it does not pass through the origin. It passes through the point 0,1. Okay? All right, so now some notes here. So for 0 is less than or equal to x is less than or equal to 2 pi, the sine function has its maximum point at 1, its minimum point at -1, and its intercepts at multiples of pi. So at pi, 2 pi, 3 pi, every multiple of pi, it crosses the x-axis. So those are the intercepts. For 0 is less than or equal to x is less than or equal to 2 pi, the cosine function has a maximum point at 1, its minimum point at -1, and its intercepts are at pi halves, and then add pi to it. So pi halves, 3 pi halves, 5 pi halves, 7 pi halves, and so on. Okay. Okay, so what I would like you to do on practice 1A, just from what I've shown you, what I've talked about there, I want you to draw a rough sketch of the sine graph and the cosine graph. But do it in pencil just in case you're off, because we'll correct it. So just a rough graph. It does not need to be perfect. And then I'm going to show you how to check it with your calculator, but try to just do a sketch without using the calculator for right now. Okay, so again, I'm not really wanting perfection here, but so for the sine graph, now I've drawn more than 2 pi. So if you actually just want the positive part, what I'm looking for is for the sine to go through the origin, and then it goes up to 1, crosses at pi, and then comes back down to 2 pi. Whereas the cosine starts here at 0, 1, and then goes down, and then comes back up. And so at 2 pi, it's back up to 1. Now, to check these on the calculator, to put it in the calculator, the big thing that you've got to know is whenever you're graphing trig functions, you need to be in radian mode. Okay? So check to make sure that you're in radian mode. And then go ahead and type in y equals sine x for y1 and y equals cosine x for y2. Now, typically when you're graphing, you want to show a couple of periods. So one of the things that's nice is if you press zoom trig on the graph, it will take your graph from negative 2 pi to positive 2 pi. That's the window. And so that's kind of nice. So zoom trig, you'll actually graph 2 periods of each. Okay. All right. So anyone have any trouble getting this to appear on the calculator? Okay.
We are.
Oh, okay. So, first of all, are you in radian mode?
Yes.
Okay. So then press y equals. Okay. And then you did sine x. And then for y2, type in cosine x. Okay. Now press graph. Is it showing up? Yes. Okay.
Yeah, it is.
Okay. All right. Any other questions on that? All right. Now, for the reciprocal functions, you've got to remember, again, for like the secant is the reciprocal of the cosine. Cosecant is the reciprocal of the sine. So what you do when you're trying to draw graph secant or cosecant, what I do is I graph sine or cosine first. So graph the reciprocal function. Okay. So first, graph the cosine or the sine, whichever is the reciprocal, and then find the vertical asymptotes. The vertical asymptotes will help you get the correct graph. All right, so this is what you do. So let's say I'm graphing the cosecant. Then I want to graph the sine first. So here's the sine here in blue. All right, now, everywhere the sine is 0, see 1 over 0 is undefined. So everywhere the sine is 0, the cosecant is undefined. So everywhere it crosses the x-axis, the sine crosses the x-axis, I draw a vertical asymptote. And then, see, the cosecant and the secant they look like little horseshoe shapes. They're these U shapes that go between the vertical asymptotes. And they go up forever or down forever. And they just touch the top and the bottom of the sine or the cosine. So you've got to make sure that you have the reciprocal function drawn correctly. So for practice 1B, to graph the secant, what are you going to graph first? What trig function do you graph first to get the cosecant? To graph the secant, you graph the cosine. So draw the cosine first, then find the vertical asymptotes, then graph the secant. Right, the reciprocal function. Okay, so when you've got it, you can come up here and check. So here the blue is the cosine. Goes through 0, 1, and then it goes off in each direction. So then where it crosses the x-axis, that's where these little circles are. So that's where you make your vertical asymptotes. And then you make your little u's. Going up, going down, going up, and so on. All right. So you see, when for the cosine, see if you start here and end here, that distance is 2 pi. That's its period. So to get the period of the secant, it's 1 u up and 1 u down. So that would be from negative pi halves to 3 pi halves. So that's also a distance of 2 pi. Or you could say from the middle of this to the middle of that. Okay. So any questions on that? All right, so the period is how long it takes to complete one cycle. So the period of sine, cosine, cosecant, and secant is 2 pi. The period of tangent and cotangent is pi. All right, so before class tomorrow or Thursday, I would like you to do practice 2A. So graph, and you can do it on the calculator if you want, and just do a sketch there. Or use the graph that you had below or whatever. So verify the period of those two functions. Okay? All right, so no quiz tomorrow. Have a great day, and we'll see you on Thursday.
Thanks, Mr. Strong.